Alright, so we have already multiplied and divided both rational expressions. So the next thing to do is to add and subtract rational expressions. So this is lesson 4.3. Add and subtract rational expressions. So you can put 4.3 here at the top. Add and subtract rational expressions. Well, Brooklyn gave me a pen. Well, I used to use a stylus, and it was big and fat, and then didn't work, so then I used my own finger, and that worked for a little bit, and then this is a really skinny little pen. I've also been doing it longer than she has. Okay, add and subtract rational expressions. So, if you can recall from, like, fourth grade, if you have 1/2 plus 2/3, what do you have to add those two together? Common denominator, right? And so the common denominator between 2 and 3 is what? 6. So then we have to think about, first of all, how did you get to 6?
2 times 3.
We multiplied the denominators by each other, right? And that gave me 6. So remember, you would then multiply this by 3 over 3, and this by 2 over 2, right? You guys remember doing that? Okay, we talked about this last week when we were doing AccuPlacer. Okay, well, whatever, it just went away. All right, so we're going to do the same thing today. All right, so remember, if your denominators are the same, though, if you have 1/2 plus 5/2, aren't you allowed to just add the numerators together? 1 plus 5 gives you... Do you add 2 and 2 to make 4? No, you just leave it as 2, right? And then you would reduce. So we're going to do the same thing here with our rational expressions. So look at example 1. Denominators are the same, right? So we're going to go ahead and make this denominator become 4a squared. The denominator is 4a squared, right?
You're adding, though, not multiplying.
No,
I'm talking about my denominator is 4a squared.
Oh, right.
Okay.
I'm fine with that. Excuse me.
So then in the numerator, we're going to add 13a plus 5a. Please write this step down. I know it seems silly, but what's coming up is going to help us here. Okay? So 13a plus 5a gives me 18a over 4a squared. Now we always have to reduce. So that should actually be step number 4 up here. Reduce, which they say simplify, but it means the same thing as reducing.
I have a question.
Sure.
Whenever you're adding the 13a and the 5a, why wouldn't you put a square over the 18a?
Because if you added 4x plus 2x, is that 6x squared, or is that just 6x?
Just 6x.
That's right. So when you're adding and subtracting, it's just 6x. You don't change your variables, okay? Or you don't change your exponents. All right. Can we reduce 18 over 4? By 2, right? Not does it go evenly, but can you reduce it by the same thing? So 18 divided by 2 is 9. 4 divided by 2 is 2. Can I reduce a over a squared?
Yes.
I can, right? I have 1a left where? In the denominator or the numerator? Good, denominator. So my final answer would be 9 over 2a.
Oh, we're not done yet.
All right, number 2. What's our denominator going to be? 16. So I'm going to draw a big line, and then I'm going to put a 16. The reason for that is because when this is subtraction, notice it's subtraction here. It's subtracting this entire second term, which means we're going to have to distribute the negative sign here and here. So it's saying subtract the entire second term. So that's why we're going to draw one big line. We know this is 9x plus 12. That didn't change. But then I have a minus 7x And what kind of a 2 is that going to be? Negative 2. Right? Now we can combine like terms, but I want you to make sure you see that when it's subtraction, you have to change your signs. That's why we write it over one big thing, okay? So now we can say, okay, what's 9x minus 7x? 2x.
Forgive me, but how did you come to the negative 7x and negative 2?
Okay, so because I said that this was subtraction, right?
Right.
And when it's a subtraction, you're distributing that subtraction sign. So that's how we got a negative 7 and a negative 2. Because it's subtracting that entire problem, not just the 7x, but the entire problem. So your negative sign has to be distributed.
Oh, so basically just combine them into one lump problem, basically.
Yes. So then 12 minus 2 is what? Positive 10. All over 16. Can we factor the numerator? 2x plus 10. Can you factor that at all? You can take a 2 out. So let's take a 2 out, which leaves me with x plus 5 over 16. Okay, so I just pulled the 2 out. Can I reduce 2 over 16? 2's on the outside, so it's by itself. Can we reduce 2 over 16? Okay, this becomes a 1 and this becomes an 8. So my final answer would be x plus 5 over 8.
I have a question.
Okay?
Now up here, I got the same thing, but I didn't factor. I don't know.
Yeah, you did factor. You did this, though. Watch up there. You did this. 2 and that 5 and then that 8. You pulled a 2 out of everything.
Is that wrong
Right?
to do?
Well, it's going to catch you up if you pull it out of the wrong thing. Right? So that's why I said factor the top, factor the bottom, and then cancel. All right?
Would cross multiplication be a proper method to complete this problem?
No, because we're not multiplying anything. We're adding and subtracting.
Okay, let me rephrase. Butterfly method.
No, because we have common denominators.
Okay.
Okay, number 3. Denominators are the same, right? So we're going to go ahead and write that once. Y squared minus 9. We don't need to factor it right now. And then I'm going to write the entire problem over y squared minus 9. It's a plus, right? We're adding, so none of my signs are going to change. So plus 2y plus 21. Everyone okay with that so far? I just put them in together. Okay, so then that simplifies to be y squared. What? Why does it keep doing that? Plus 10y plus 21 over y squared minus 9. What? Can you cross the y squareds out? What do you think? Why not? Yeah, it's connected, right? However, this problem now looks like what we just learned in the previous lesson, where you factor the numerator, you factor the denominator, and then see if there's anything to cancel. So in my numerator, that's an x factor problem, right? What two numbers multiply to get 21 and add to get 10? 7 and 3. Okay? So I know that my numerator factors to y plus 7, y plus 3. What about the denominator, Taylor? What is y squared minus 9 factor to?
Y minus 3 and y plus 3.
Okay, y minus 3, y plus 3. And now, what do you guys notice? You can cancel now the y plus 3 and the y plus 3, which leaves you with y plus 7 over y minus 3. But had you stopped here and not factored, you wouldn't have gotten to the right answer. Okay? So we're going to add and subtract, get our answer, then always check to see if it can be factored again. All right? Let's look at number 4. Denominators are the same, right? So I'm going to write that one time. 12a minus 3. And then in the numerator, it's a subtraction sign, so I'm going to distribute it. 1 minus 16a squared. So everything is simplified. I can't simplify it, and I can't combine any other like terms. So once I'm done combining like terms, what do I check for?
Common factor.
Common factor, see if I can factor anything. Can we factor the denominator? Let's look at the denominator first. What do they both have? A 3, right? So let's go ahead and factor the denominator. Pull a 3 out, which leaves me with 4a minus 1. What about the numerator? What can the numerator factor to? What do you notice about all of those things? Ooh, perfect squares, right? So I have to put the 1 first because that's what it gave me. 1 minus 4a and 1 plus 4a. You guys okay with that? Now, something looks similar, right? We have a 1 minus 4a, and then we have a 4a minus 1. Are they the same thing?
No.
They're not the same thing, but what did we learn earlier today? What are you allowed to do?
Multiply negative.
Okay, so we can, on this first one, I can pull a negative 1 out. So if I pull a negative 1 out, that leaves me with negative 1 plus 4a. I just changed the signs of that first one.
You don't do it to the other one, though?
Nope, I don't do it to the other one unless I want to pull another negative 1 out. So I changed that first one by putting a negative 1 out, which changed my signs. And now I have 3 over 4a minus 1. Okay. Do you see that this and this are the same thing?
Mm-hmm.
They are, right? They're just flipped around, but they're the same thing. So if they are the same thing, I can do what with them? Not cancel them, right? So this is gone and this is gone. So in the numerator, the only thing I have left is negative 1, doesn't go away, times 1 plus 4a. And then what do I have in the denominator? 3. So that one was kind of loaded. Questions on number 4? All right, why don't you try number 5, see what you can come up with. It is a subtraction problem, so what do you have to be careful with on number 5? That you change the signs of both that n plus 1, okay? Take a few minutes and try number 5. Give it your best shot.
Oh, okay, but we only change the sign in the numerator, right?
Yes, only the signs in the numerator. Good question. Okay, look at the board and see if you are this far. This isn't the final answer, but if you're this far, raise your hand. At least this far. If you're farther, that's fine, but if you're at least this far. Good, 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 good. Okay, so now what should we do to just double check? We should probably check to factor the top and the bottom. And they both can be factored, right, because they're trinomials, so we can set up our x factor. So you have some space out there to the left. Take a few minutes, and I want you to factor the numerator and factor the denominator, please. Yes?
Why is the negative n negative 1 in the first item?
Why are they negative?
Why are they on that side?
Because remember, the first step is to write this whole thing on one problem. That's what we've done in the first 4 problems. We wrote this all over one big denominator. Mm-hmm. This one? I'll show you in just a minute. All right, if we're factoring, get n plus 4, n minus 2 on the top, n minus 2, n plus 3 on the bottom. So we can cancel out our n minus 2's, which gives me n plus 4 over n plus 3. Raise your hand if you have this final answer, please. Okay. If you did not get this final answer, what is your question for me?
I'm slow assembling.
Okay, but you were on your way, right?
Actually, I was kind of stumped at X factor part, but
Okay. Lexi, where's your struggle?
What is it n squared plus 2n minus 8?
Okay. So when I combine like terms, right, n squared stands alone. 3n minus n gives you 2n.
Okay.
And then negative 7 and negative 1 gives you negative 8. You okay there? Okay. All right. Let's go down to number 7 and see what happens when you have unlike bases. Okay, so we already talked about if you have unlike bases, you need to get a common denominator, right? So what would be the common denominator between 2x and 3x? 6x, right? Do you notice that they both already have an x, right? So we don't need to multiply them by an x. The way that you can ask yourself this is, listen carefully, watch up here at the board, what is this fraction missing that this one has? And what would you guys say? In the denominator. It's missing a 2, right?
Yeah.
What is this fraction missing that this denominator has? They already have an x, right?
Yeah.
But it's missing a 2. Okay? So that means I'm going to multiply this side by 2 over 2. Okay, so go ahead and write that down, 2 over 2.
you're allowed to do that.
What is 2 divided by 2?
1.
So we're really just multiplying the problem by 1. And if you're multiplying the problem by 1, is it changing the value of the problem? If you multiply something by 1, Crystal, is it changing the value of it? No, right? 100 times 1 is 100. 1,000,000 times 1 is 1,000,000. So we call these fancy ones. 2 over 2 doesn't really look like a 1, but we're going to call it a fancy 1.
Or a mathematical loophole.
It's not a loophole, though. It's a process that works. So then, if we look at what is this fraction missing that this one has? Brooklyn said a 3. Would you guys agree with that?
Yeah.
So that means I'm going to multiply this one by a 3 over 3. And we're multiplying. Okay? So 3, I'm going to multiply top with top and bottom with bottom. 3 times 15 gives me 45 over 6x. And 6 times 2, 32 over 6x. We can solve this, right? Denominator is the same. What is 45 minus 32? 13. So I have 13 over 6x. Can this be reduced at all?
No.
Okay. All right, so we're doing that same process. So let's look at number 8. So we're going to ask ourselves, what is this fraction missing in the denominator that this one has? An a squared, right? But doesn't this fraction already have an a? So it just needs what? Another a, right? So we're going to multiply this side. Good. A over a.
That's what I thought.
And then you're going to ask yourself, what is this fraction missing that this one has? It's an 8, right? It's missing an 8. So that's what we're going to multiply by. 8 over 8. Because remember, if you do 8 over 8, it's still the number 1. Okay, so let's multiply the numerator. Gives me 32a. My denominator is 8a squared minus 7a. Still have 8a squared. 32a minus 7a, I can combine those. What is 32a minus 7a? 25a over 8a squared. Can we simplify anything? Can we reduce anything here?
Oh wait, but no, never mind.
Can you reduce this?
Oh.
Can you reduce that?
Yeah.
You can, right?
I wanted.
So can we reduce a over a squared? Okay, so go ahead and reduce a over a squared. See what that leaves you with. Okay, so if we knock out an a, that leaves me with 25 over 8a. Is that what you guys have? All right. Sweet. Moving right along. You guys look so excited to be here today. Doing a good job of pretending. All right, so let's go down to the next page because it's going to get, I know, it's going to get a little trickier. But we can still handle it. Okay, so let's make ourselves a note on the left side here. We have some space. The first thing we should do is factor the denominators. Factor denominator to see what's missing.
Is it okay to just say top?
But the denominator is the bottom. So you want to make sure you make that adjustment.
I always confuse those.
Factor the denominator to see what's missing. And then step number 2 is find what we call the LCD, which is the least common denominator. Okay, so number 9, now we're worried about factoring the denominator because we don't want to just multiply by k minus 2 and 5k minus 10 because that's going to create a lot of extra work for us. So the first denominator, 5k minus 10, what can we factor out here?
5.
Not a 2, a 5, right? Which leaves me with k minus 2. Okay, so we're going to cross that denominator out because now we made it k minus 2 with a 5 on the outside. Now what do you notice? They both have a k minus 2, right? So what is the second fraction missing that the first one has? A 5, right? So we're going to multiply by 5 over 5. Is this fraction missing anything that this one has? No. So we don't even have to multiply the first fraction by anything because it already has everything it needs. All right? So I'm going to write the first fraction down as is, k squared plus 16. I'm going to leave the bottom or the denominator factored. Go ahead and leave that factored. Good. Then I have a minus sign here. 4 times 5 is 20, right? And then I have that 5k minus 2 left outside. It's okay to move the 5 to the front. It means the same thing, and it's going to look better. It's going to look more like the first one.
Why didn't you multiply the 2 by the 5?
So we would have had to distribute up top, right? I would have had to distribute 5 here and 5 here, right? But remember I said in the first one we're going to leave it factored as is, okay? So we'll leave our denominators always completely factored. Okay, now we have this thing called LCD. LCD means least common denominator. Do you agree that this is your LCD right here? This is your LCD, right? All right, so now if I am going to simplify the top, I have k squared plus 16 minus 20, and I'm going to put it over LCD. The reason we're using LCD is because we're going to have to do some work in our numerator, and if we have to write the denominator every single time, it's going to get tedious and it's going to be extra work for us, okay? So while we figure out what's going on in the numerator, we're just going to leave the denominator as LCD until the very end, and then we'll put it back in there, okay? So k squared plus 16 minus 20, how can that be simplified? Well, can you put 16 and negative 20 together? Minus 4 over our LCD. What is k squared minus 4 factor to? K plus 2, k minus 2. Is there anything else we can do in the denominator or in the numerator in the top? There's nothing more I can do, right? So now when we're at the final straw where I can't do anything else, now I can rewrite my denominator, which was 5 times k minus 2. Say that again, Lexi. Can you cancel anything here? You guys see the k minus 2 can cancel? Now, Mitchell, if you had gone ahead and done 5k minus 10, right, like you kind of wanted to, you wouldn't notice that this is going to cancel with this, right? So that's why we always leave it factored, okay? So my final answer is going to be k plus 2 over 5. Yes, that seems like a lot of work for one problem. Yes. My apologies.
How do you know what the LCD is?
When you finally, okay, did you hear what she just asked? How do you know what the LCD is? When you finally see that you have the same thing in common, then that's going to be your LCD, right? Up here we had to do some work to try to figure out what it was, but then when I see it's the same, I know that's my LCD. Okay? Good question. All right, let's look at number 10. What did I tell you to do first over there? What's our number 1? Factor the denominator, right? To make sure you don't do any duplicates. Because, guys, wouldn't it be a nightmare to try to do this? Y squared plus 11y plus 24 over y squared plus, like, that's going to be ridiculous to try to do that on both sides, right? So to prevent ourselves from having to do that, let's figure out if there's something that they have hidden that's the same, okay? So the first fraction can't be factored at all. But the second fraction, that second denominator can, right? What two numbers multiply to get 24 and add to get 11? 8 and 3. So I know that this denominator becomes y plus 8 and y plus 3. So we're going to ask ourselves, what is this denominator missing that this one has? Y plus 3, right? They both already have a y plus 8, okay? So this one's missing a y plus 3. So that means I'm going to multiply top and bottom by y plus 3. Still the number 1, right? Because anything divided by itself is 1. Now, if I ask myself, what is this fraction missing in the denominator that this one has, what would you say?
Y plus 3.
Doesn't it already have a y plus 3?
Oh, what?
Is this second fraction missing anything in the denominator that this one has? No, it's the same. So I don't need to multiply by my second fraction by anything. Okay? So let's go ahead and multiply the first fraction. We're going to distribute our 7, right, here and here. So I get 7y plus 21 all over y plus 3 times y plus 8. Remember, leave your denominator factored. Plus 35 over y plus 8, y plus 3. Do you see now that I have the same thing in my denominators? So there's your LCD. Does that make sense, Samantha, that time? Okay. So now that I have the same thing in my denominator, I'm going to go ahead and write my numerator as one big thing, 7y plus 21 plus 35 over my LCD. Again, the LCD is just a placeholder, so we don't have to keep writing it every time. Okay, let's simplify. What is 21 plus 35? 56. So I have 7y plus 56 over my LCD. Aspen? Okay, Aspen noticed, hey, I have a greatest common factor in my numerator. It's a 7. What did you say that leaves us with?
Y plus 8.
Okay. Now, we can't do anything more with that 7 and y plus 8, right? It's all the way done. It's all the way factored. So now, what do we put back in our problem?
The LCD.
Good, our LCD, which was... I apologize if you're running out of room. Just try your best. You can go off to the left or the right. You have plenty of room over there. And now we can cancel y plus 8 and y plus 8. So we're left with 7 over y plus 3. Give me a hand figure 1 to 5. 5 is, this is freaking easy. Number 1 is, what are we doing?
I've noticed.
It's okay. It's okay to be honest. Okay. Okay. All right, let's do 11. Okay, so again, what's the first step? Factor your denominators, right? Okay, so let's factor on number 11. You can factor that denominator. You have plenty of space over there on the left. We're not going to use that space, so you can use the space there on the left. Yeah, number 11. We just have a couple more examples and then we'll be done, okay? Which numbers multiply to get 6 and add to get 5? So this denominator becomes x plus 2, x plus 3. Is that what you guys have?
I got 6 minus 1.
But that would be a negative.
Yeah,
And
the
it's not a
negative
right, but it's not a negative 6. It's a positive 6. Okay, so what is the second fraction missing that the first one has? Good, x plus 3. So on top and bottom, we're going to get an x plus 3. Is the first fraction missing anything? It's the same, right? X plus 2, x plus 3, x plus 2, x plus 3. Okay, so guys, pause for just a second. even here at this point, you can see your LCD,
I was gonna
right?
say that
It's the
last
same.
time.
You guys see that even at this point, you can see your LCD. So make a note whether it's something like this where you're writing LCD, okay? So you remember when you go back to plug it back in. Okay, so the first fraction isn't going to change. It's just x squared minus 5 over LCD. The first fraction we're going to have to, or the second fraction we're going to have to distribute that 1, right? So that's going to give me x plus 3. So now that I have the same thing, I can write it once, right? So x squared minus 5 plus x plus 3. I'm just writing it all 1 over one big LCD. Now we combine like terms, right? So the x squared is by itself. That doesn't combine with anything. That x is also by itself. And then negative 5 and positive 3 make negative 2 all over my LCD. If I'm going too fast, tell me to slow down. Are we ready to put our LCD back in?
No, because you put
We got to check to see if we can factor, right? So if I'm x factoring, what two numbers? Multiply to get negative 2 and add to get 1. Ryan?
1 minus.
Ryan? And what? Positive 1. Is that when I add those together, am I going to get a positive 1? When I add these together, am I going to get a positive 1? No, so what do I need to do with my signs? Switch them. Good. Okay, so this numerator factors to x plus 2, x minus 1. Now are we ready for our LCD to go back in there? Okay. So I have x plus 2 times x plus 3. Hey now. Hey now. What are you going to do, John?
I messed up a step back. And
Okay. Look at what I have up there. If you were here, what would you do now?
you can cancel the x plus 2.
Perfect. And we are left with x minus 1 over x plus 3.
So I've noticed that like what we multiply by is what our denominator, what we end with. You get what I'm saying? Like we, on each of them, we've, like for instance, that when we multiplied that one term by x plus 3,
What a,
and like at the very end, our denominator is always.
That won't always happen. Okay.
Has
Yeah, so I'll show you in number 13.
what would a safe method in these cases be? Basically, once we find our once we factor the trinomial denominator, whatever that turns out to be, would it be safe to say we just whatever's missing from the side, we just basically add to the top and the bottom, basically?
In step number 1. Up here.
Yeah,
Yes.
basically like a,
Yes, so I factored this, and we said this one was missing an x plus 3.
Yeah, I mean,
Yes.
it's obvious that we're gonna multiply. So obviously multiplying it, but I'm just saying, in that situation, I noticed that you're basically just adding the.
You're seeing what the other one is missing. Yes. Okay, 13 is going to be our last example. Okay, this one's a little bit different. Is there anything to factor in number 13? Okay, so now I'm going to step number 2 where it says make them the same, right? Find the common denominator. What is this fraction missing that this one has? Not just a negative 7, right? Because it goes together. It's missing a what? Say that again, Olivia. It's missing the entire w minus 7, right? It doesn't have a w minus 7 because remember, they get stuck together, right? W plus 1 is one entire term. Okay? So it's missing, the left side is missing a W minus 7.
You can't multiply, otherwise that becomes a.
So I'm going to multiply W minus 7 over W minus 7, which is what you just told us to do.
But that turns into a square, which would mean you would have to.
Okay,
multiply
but
the
do
other
we
one by the same.
Do we multiply the denominators out, or do we leave them factored? We leave them factored. Okay, what is the second fraction missing that the first one has? A W plus 1. Okay? Do you notice now that our denominators are the same? I have a W minus 7 and a W plus 1, and so now I have created my LCD. Guys, you need to mark on your paper LCD, whether it's a bracket like this or whether you write it off to the side. Somewhere on your paper you have to mark that that's the LCD if you're going to use the letters LCD. Okay? Now we start multiplying. So if I'm going to multiply the first, I'm going to multiply 5 times each of these. So I get 5W minus 35 over LCD. What about that second group? Brooklyn, what does that second group become? Top? Yep. Plus 1 or plus 8? Good, because you have to distribute. Okay? So then I write one big LCD. Put them all on the same line together. Why don't you see what you can do to finish this problem?
Is it okay if I basically skip that step and just put them all together, and by doing that? Because it takes up space.
So because there's nothing more you can do with 13W minus 27, our problem is finished. So now we're going to write our W minus 7 and W minus 1. So not always will something cancel out. Is it plus 1? I'm sorry, yes, you're right. Thank you, Samantha.
I have a question.
Yeah.
Where are you getting the W plus 1? Is that from your original?
Right, that's our LCD, right?
Yeah.
So that's what took the place of our LCD up there. Okay. All right, any questions on number 13? All right. For your homework today, I'd like you to do 1 through 17 odd. 1 through 17 odd. Let's take a look at number 15 on page 14. On page 14, look at number 15. It just has a 4. Donald, what did you just do? Tell your classmates what you just did.
I put it over a 1.
Put the 4 over 1, right? And now you have a fraction that you can continue to work with, okay?
So you put on 14 or what?
Page 14, number 15, there's just a 4 there. So you can put a 1 on the bottom.
Yeah, I was going to do that myself.